Welcome to Lesson 1-3. You can open your online textbook and copy some definition terms. I'm kind of giving you the simplified generic version of them as I talk through some of these pieces of information. But this lesson is all about classifying numbers and comparing numbers and naming numbers. So the first thing I'm going to go over is this diagram here we have, and we're looking at all real numbers. Real numbers are any number that you can touch or count or compute with, okay? So we've got two types of real numbers. We've got rational numbers and irrational numbers. Rational numbers are all of those numbers that have kind of, they're either a pattern to it or it ends, okay? Where irrational numbers, there's kind of no rhyme or reason to them. They go on forever. They don't have any patterns. They don't repeat. Things like square roots and pi is the most famous irrational number there is. Those are going to go on forever. They're not going to end. They're going, and then they're not going to repeat, okay? And there's no rhyme or reason to it. With rational numbers, you've got a couple of different kinds of rational numbers. You've got rational numbers that are decimals or fractions or repeating decimals. And then you have special rational numbers like integers. Integers are going to be whole numbers. They could be positive or negative. And then we have whole numbers themselves. And whole numbers are going to be obviously what the things that you learned. Think back to preschool and kindergarten, things, counting numbers that you use on a daily basis. 0 is also considered a whole number. If we look at some things, we have some names for them. We have our natural numbers. Natural numbers are counting numbers. Naturally, when did you learn to count? Did most of you start at 0, 1, 2, or did you learn to count at 1? Most of us learn to count at 1. That's the natural numbers. 1, 2, 3, and so on. Then we get whole numbers. Whole numbers are basically your natural numbers with 0. So whole numbers, 0 is considered a whole number. And then we have integers. Integers are going to be the whole numbers and their opposites. So the only number that doesn't have an opposite is what? 0. Okay, 0 is still an integer and it's a whole number, but it's not a natural number. And then we have rational numbers, and again, these are all my little quick definitions for them. You're welcome to open up the book and use your glossary and get a formal definition as well. Rational numbers are any numbers that can be written as a ratio of two integers. Ratio. The word ratio, what does that mean? That's just a fraction. Any number that can be written as a fraction is going to be a rational number. Any fraction, just so you know, is a rational number. That tells you that it's going to either end or terminate or repeat at some point. So that's a good clue as to whether it's a rational number or not. Irrational numbers are numbers that cannot be written as a ratio. These numbers in decimal form are non-repeating, and again, they never end. Moving on to real numbers could be rational or irrational. And then we have some of these funny little phrases. Counterexample is an example that proves a statement false. Okay, that's a counterexample. So if I say I am perfect, and then you say, Mrs. Mona, you have a mistake on the board, that's a counterexample to prove my statement false. An inequality is a statement that compares two expressions using an inequality symbol. These are your greater than or less than symbols usually. Opposites, the number that's the same distance from 0 but in an opposite direction. And then absolute value is the distance from 0. And this was the one I think a lot of you missed when I had that first week challenge. Okay. Now, let's look at some examples. We have classify these to set. So it's -13. So if you think about it, -13 is going to be an integer. It's a rational number as well. Okay. It's not a whole number. We have 3.28. Is that a whole number? No. It's not an integer, but it is considered a rational number. So let's use a counterexample here. Determine whether the statement is true or false. If it's false, give our counterexample. So all negative numbers are integers. All negative numbers are integers. Well, a negative number can be a fraction, right? such as negative 2/3. So this is not an integer, right? Negative 2/3 isn't an integer, so therefore the statement is false. So we just gave a counter example here that all negative numbers are integers. No, negative numbers don't have to be integers. They could be fractions as well. They could be decimals. They could be even irrational, a negative irrational number. Can you think of one of those? Okay, great. All right, moving on to example 3. We're ordering fractions. Now remember, when you're ordering fractions, it's going to be with negative numbers, the closer to 0 it is, technically the bigger it is. Okay, so we're going to order these from least to greatest, and negative 3/4 is going to be further away than negative 5/8, and then negative 12 or 7/12 is going to be the greatest number, and that's going to be closer to 0 than the negative 3/4. Okay, absolute value. Absolute value is just the distance from 0. So if you have the absolute value, notice the absolute value bars here, okay? The distance from 0 of negative 2.5. Well, guess how far that is? It's 2.5. How about 7? The absolute value of 7, the distance from 0 to 7 is 7. Go ahead and pause and do the quick check, and then when you're ready to check your work, come back. And again, if you have any questions or issues with any of that, please feel free to ask. Okay, so we're looking at naming the sets of numbers to which they belong. Negative 12 is an integer and a rational number. B, 5/12 is a rational number. It's not an integer. It's not a counting number. Negative 4.67, that's a rational number. 6 is a whole number. It's an integer. It's a rational number, and it's a natural number. You learn to count with the number 6. Okay, our final or quick checks here, we have is each statement true or false? If it's false, give a counter example. So all whole numbers are integers. Yes, they are. Are all integers whole numbers? Not necessarily, but all whole numbers are integers, so that is true. No fractions are whole numbers. That I can give you a counter example here. 4/2 is a fraction, but it's also a whole number, so that statement is going to be false. Ordering 1/12, negative 2/3, and negative 5/8. Again, from least to greatest. So we're going to take our smallest number here, which is going to be negative 2/3, and then negative 5/8, and then 1/12. A good way to do this would be to add these to a number line, and then start with your least, which is the leftmost, and work your way to the right. Finding absolute value, the absolute value of 5 is 5, the absolute value of negative 4 is 4, and the absolute value of negative 3.7 is 3.7. The absolute value of 5/7 is 5/7. I believe we are done. I'm not sure what your homework is going to be yet, but if you have any questions, please ask, and I will hopefully get back to you. If you don't have time to ask in class, please send me an email.